Can you actually believe people thought California was just gonna, like, slide into the ocean?
Yeah, well,
It's wild, the kind of stuff that gets traction when the ground starts shaking, you know?
it really is. And that's just one of the wild ideas we're going to unpack today. Yeah. They dig into what the planet's really been doing under our feet.
Right here on the deep dive. And maybe more importantly, what can you actually do when it happens, when a ground starts shaking?
So we've pulled together a whole bunch of sources looking at global seismic activity, particularly focused on this, well, significant spike we saw over July and August of 2025.
Okay.
Our mission today, basically cut through the noise, try to understand these like massive forces,
Yeah.
and give you the real insights into how our, well, dynamic Earth actually works.
Okay, so to really kick things off, we have to talk about that huge one.
Well,
That magnitude 8.8 earthquake off Russia's Kamchatka Peninsula, July 30th.
right.
I remember seeing the first reports saying like 8.0, and then it just kept getting revised. Up and up again. Why is it so hard to nail down the size of those huge quakes quickly, even with all our tech?
That's a great question. And it really shows the complexity, doesn't it? I mean, these events, they generate just a colossal amount of data.
Right.
So it takes sophisticated modeling and honestly time to really get the full picture. That Kamchatka tremor, it was a mega thrust rupture.
Mega thrust. Okay.
Yeah, where one tectonic plate is basically sliding under another one. But what's really fascinating here, I think, is why the immediate impact, especially the tsunami, why it was less devastating than you might expect for an 8.8.
Yeah, I was definitely surprised. I mean, the tsunami warnings went out everywhere. Across the Pacific, Japan, Russia's Kuril Islands, even the U.S., Hawaii, New Zealand, they were all on alert. And the actual stories coming out. Video of the ground shaking like crazy, an earthquake hitting mid-surgery in Kamchatka.
Yeah, that one.
And then that volcano, Kloshevskoy, erupting shortly after. That's,
Okay.
I don't know, that's a new level of terrifying to think about.
It really is. But the relatively limited damage, despite that size, it was because the earthquake slip, that's how much the fault actually moved.
Okay.
It was focused deeper down, around 25 kilometers deep. And when that movement, that slip, happens deeper, you get less vertical sort of push on the seafloor.
Less displacement.
Exactly, less displacement. So less push or pull on the ocean water itself. And that means a smaller tsunami than you'd typically get from an 8.8 near the surface.
And less intense shaking for people nearby, too.
Precisely. Deeper slip generally means less intense shaking felt at the surface directly above.
But it wasn't just Kamchatka, was it? Our sources showed, like, a whole cluster of activity around that.
That's right. Yeah, we saw a magnitude 5.0 quake also near Kamchatka's east coast.
Yeah.
And then a whole series, 5.4 to 5.8 in the northern Maluku Sea. That's near Halmahera, Indonesia.
Wasn't that on a full moon, August 8th? Kind of weird.
It was, yeah, August 8th. And beyond that, the sources list a 5.3 near Vanuatu, another 5.0 in the North Pacific, a 5.1 back near Kamchatka, 5.3 east of the Kurils, and a 6.0 on Papua New Guinea. All within like a few days in early August.
Wow.
There was even that Reddit post going around, global earthquakes in 3 days. It highlighted the big 8.8 and also this weird swarm of quakes at Mount Rainier.
Because it really wasn't just one big event. It's like a snapshot of the whole planet being constantly active.
Exactly. You know, it just paints this picture of constant, widespread tectonic forces. It's a reminder, you know, even in places we might not think about, like those smaller quakes reported in New York City or Ontario, California. This constant motion from tiny tremors to that massive Kamchatka quake, it really underscores the immense forces under our feet. And to really get what's happening, we need to talk about those giants, the megathrusts.
Right.
These are the biggest earthquakes. They happen to subduction zones. That's where one tectonic plate gets forced down, sliding right underneath another one.
And most of that happens along the Ring of Fire, right? That's where the really big ones tend to hit.
Exactly right. The Ring of Fire, or the Circum-Pacific Seismic Belt, it's this big horseshoe shape. It goes from Chile up the west coast of the Americas, through the Aleutians, Japan, Philippines, New Guinea, down to New Zealand.
Okay.
Something like 81% of the world's largest earthquakes happen there. There are other belts, like the Alpide Belt, that gets about 17%, and the Mid-Atlantic Ridge. But, you know, while we often worry about places like the U.S. West Coast, it's worth remembering the deadliest quakes in history weren't there.
Really?
Yeah. Like 1556, Shenxi, China.
Yeah.
Killed around 830,000 people. Just staggering.
Wow. 830,000.
And Tangshan, China, 1976. Estimates range from 250,000 up to maybe 800,000 deaths.
Those numbers are hard to even comprehend. It puts things in perspective, especially when you think the strongest recorded quakes were, Chile 1960, M9.5, and Alaska 1964, M9.2, still massive, but the death tolls in China.
Different circumstances, destruction, population density, lots of factors. But it leads us to a pretty stark warning coming out of Japan right now.
About
the Nankai Trough.
Oh, yeah, I saw that. The sources mentioned a 70–80% chance of a magnitude 8 to 9 earthquake there within the next 30 years.
That's the assessment, yes.
Yeah.
A very high probability over that time frame.
That feels incredibly high, especially with all those recent small quakes in southern Japan. Didn't they have over 1,000 minor tremors in just 13 days? Doesn't that make it feel like it could happen, now?
It's a very understandable reaction, absolutely. And it's crucial to get the context right. Yes, the Nankai Trough has a high probability, statistically speaking, but that's a long-term forecast. It's based on decades, even centuries, of historical quake cycles and geological data.
Okay.
Those recent tremors. They're definitely a sign of ongoing tectonic stress building up. But they aren't necessarily an immediate precursor signal that the big one is imminent tomorrow or next week. It's more complex than that.
Right. It's not like predicting the weather.
Not even close.
Yeah.
And actually, that brings us perfectly into debunking some common earthquake myths.
Okay, yeah, let's do that. Because the big one is prediction, right? The idea that we can accurately predict exactly when and where a quake will hit and how big it'll be.
Right. And let's be absolutely clear. We cannot. Unequivocally.
Yeah.
Despite all the rumors, the sensational claims you see online sometimes, scientific prediction of earthquakes with that kind of precision, it's just not possible right now.
You know, when you talk about bad predictions, I immediately think of that Ivan Browning thing back in 1990. The guy who wasn't even a scientist.
Ah, yes, the Ivan Browning saga.
Didn't he cause total panic predicting a huge one for New Madrid, Missouri?
He did indeed. Ivan Browning's zero seismology expertise predicted a massive 6.5 to 7.5 quake for New Madrid on December 3rd, 1990. And the reaction was, well, intense.
Wait, schools closed? Seriously?
Schools closed in 5 states. Over 200 media outlets sent reporters down there. People were stockpiling supplies. It just shows how easily that kind of fear can take root,
Yeah.
Especially when it touches something so basic like the ground not being stable.
And then nothing happened.
Nothing happened. Crickets. But to be fair, the New Madrid fault zone did have enormous quakes back in the early 1800s.
Right, the ones that supposedly made the Mississippi flow backwards.
That's the story, yeah. Around magnitude 8.0. Rang church bells hundreds of miles away. So the idea that the fault was, quote, overdue definitely fueled the Browning panic. People were primed to believe it.
And history repeats itself, kind of. We just saw something similar with that Ryokatsuki prophecy, didn't we? The Japanese manga artist.
The boiling seas prediction.
Yeah, she predicted the seas around southern Japan would boil on July 5th, 2025. Then, after the Kamchatka 8.8 quake hit later that same month.
People connected the dots.
Exactly. Huge online buzz. Apparently, it even caused travel cancellations to Japan, even though nothing happened on her specific date.
It's another classic case of seeing a pattern where there isn't one. Correlation, not causation. Experts were quick to point out it was pure coincidence. Okay, let's hit some other common myths. How about mega-quakes? Quakes bigger than physically possible.
Oh, yeah, like the San Andreas unleashing a magnitude 10 and California just plopping into the Pacific. The classic movie trope.
Total fiction.
Oh.
An earthquake's magnitude is directly tied to the area the fault ruptures.
Okay.
The San Andreas Fault. It's long, about 800 miles, but it's relatively shallow, maybe 10 to 12 miles deep. It simply doesn't have the physical dimensions, the sheer area, to generate anything much larger than about an 8.3.
So no magnitude 10.
Definitely not from the San Andreas.
Yeah.
And California falling into the ocean. Also impossible. The Pacific Plate, which includes places like LA and San Diego.
Yeah.
It's moving horizontally northward, sliding past the North American plate, about 2 inches a year. Like cars passing each other, but very, very slowly.
So instead of sinking, LA and San Francisco will eventually be neighbors.
In about 15 million years. Yep. And maybe 70 million years from now, LA residents might need an Alaska zip code. It's moving north, not down.
Okay, I like that visual better. What about tsunamis then? Could the San Andreas cause a huge tsunami?
Highly unlikely. Again, it's mostly horizontal movement, a strike-slip fault. You need significant vertical movement of the seafloor to displace enough water for a big tsunami like you get in those subduction zones.
Like Sumatra 2004, Japan 2011.
Exactly. Now, local tsunamis are possible in California, maybe from offshore thrust faults or underwater landslides triggered by shaking, but not a giant one directly from the San Andreas itself.
Got it. Okay, another myth. Aftershocks are always smaller than the main quake. True or false?
Mostly true, but not always. It's a common misunderstanding. The terms foreshock, main shock, and aftershock are relative, defined after the sequence happens.
Ah,
While most aftershocks are smaller, about 5 to 10% of the time in California, an earthquake is actually followed by a larger one within about a week.
so the first one becomes a foreshock.
Exactly. The bigger one becomes the main shock. So never assume the shaking is over or that the next one will definitely be smaller.
Good point. And what about when two big quakes happen on the same day, somewhere far apart? Are they related?
Usually not. That's another one that spreads quickly online. The Earth's crust just isn't rigid enough over thousands of miles to directly transfer stress like that efficiently. You can get triggered seismicity within a few hundred miles of a big quake, or maybe some very tiny, short-lived tremors detected globally right after. But two major distant quakes on the same day, generally just coincidence. The planet is always active.
Okay, practical advice time. I always heard growing up, head for the nearest doorway during an earthquake. Still the best advice.
Absolutely not. That's really outdated and potentially dangerous.
Okay, why?
Well, in very old, unreinforced brick or adobe houses, the doorframe might have been structurally stronger. But in modern homes, doorways are no stronger than the rest of the wall, and you've got a swinging door that could hit you. Plus, you're not protected from falling objects.
So what should you do?
The official advice, globally recognized now, is drop, cover, and hold on. Drop to the ground, take cover under a sturdy table or desk, and hold on until the shaking stops.
Drop, cover, hold on. Got it. And the movies always show mass panic. Everyone's screaming and running around during the big one. Does it actually happen?
Research consistently shows the opposite, actually. Most people take protective actions like drop, cover, hold on, and then they check on and help others afterwards. Widespread, uncontrollable panic is largely a myth.
That's reassuring, actually. Okay, last myth. Animals. Can they predict earthquakes? My aunt swears her cat knew the last one was coming.
It's a persistent one, isn't it? Look, animals do have senses more acute than ours. They might feel the very early, subtle P waves of an earthquake seconds before humans feel the stronger S waves.
So they react to the start of the quake, not predict it beforehand?
Pretty much.
Right.
There's absolutely no reproducible scientific evidence that animals exhibit specific behaviors that reliably predict an earthquake before it begins. Animals act strangely for all sorts of reasons. And given how many pets there are, statistically, some are bound to be acting weird just before a quake hits, purely by chance.
Okay, that makes sense. So if we can't predict them, can we cause them? That feels like a whole other can of worms.
Well, this is where it gets really interesting, actually. And the answer is yes, sometimes. Human activities can induce earthquakes, usually minor to moderate ones, though.
How?
The most well-documented ways are injecting fluids deep underground, think wastewater disposal from oil and gas operations, or sometimes geothermal energy projects.
Right, like what happened in Oklahoma. Didn't they see a huge spike in quakes?
Exactly. Oklahoma saw a dramatic increase in seismicity that coincided very closely with large volumes of wastewater injection. It's important to be clear, though, studies generally link this to the disposal wells, not directly to the hydraulic fracturing or fracking process itself, especially for the quakes magnitude 3 and larger.
Okay. What else?
Feeling large reservoirs behind dams can sometimes trigger quakes as the water weight adds stress to underlying faults. Deep mining operations can cause small, local tremors. And historically, underground nuclear testing also caused localized seismic events.
It's kind of sobering, realizing we can sometimes trigger the ground to shake, even if unintentionally. But since we can't reliably predict or prevent the big natural ones, what can we actually do? How do we protect ourselves?
That's the crucial question. We can absolutely mitigate the effects. The key takeaway here is preparedness. It's not about stopping the quake. It's about being resilient when it happens, making sure you can be self-sufficient for several days afterwards.
Okay, so practical steps. What should people listening be thinking about?
Basics first. Have a family plan. Where will you meet if you're separated? Know the emergency plans for your kids' schools or daycare. Keep emergency supplies not just at home, but maybe a small kit at work too. Definitely include comfortable walking shoes.
Good call on the shoes. What else?
Know how to shut off your utilities, gas, water, electricity if needed, and if it's safe to do so. Sometimes leaving them on is safer. It depends. Check with your local utility companies for specific advice.
And the disaster kit itself, we always hear about it, but what's really essential, beyond just Band-Aids and water?
Think about immediate survival and self-sufficiency. Yes, water, at least a gallon per person per day for several days, non-perishable food, flashlight, batteries, radio, first aid kit, but also work gloves, sturdy shoes, again, maybe a dust mask, basic tools like a wrench for utilities.
What about personal stuff?
Crucial. A week's supply of any essential medications,
Oh.
copies of important documents, insurance, ID, bank records, maybe on a USB drive, or stored securely online. Cash in small bills because ATMs and credit card machines might be down, extra keys, a map of your area, list of emergency contacts.
And things for comfort or specific needs. Diapers, formula, pet food.
Exactly. Sanitation supplies too, toilet paper, garbage bags, moist towelettes, maybe something small for entertainment, especially if you have kids, books, games.
Okay, that's the kit. What about making your home safer before an earthquake?
Huge difference maker. Secure, tall, heavy furniture like bookcases and entertainment centers to wall studs. Brace heavy appliances and electronics. Move heavier, fragile items off high shelves. Use latches on cabinets. Strap your water heater that prevents it from tipping and breaking gas or water lines. Bolt gas appliances securely.
Sounds like a weekend project.
It could be. And honestly, it's worth considering talking to a structural engineer, especially if you live in an older home, to assess its seismic safety and see if retrofitting makes sense. Bolting the house to its foundation, bracing cripple walls, it can make a massive difference.
Let's loop back to that Kamchatka M8.8 quake again. You said the damage was relatively minimal for its size. Why was that again? Beyond the depth?
Well, the depth was key for the tsunami size and shaking intensity near the source. But the relatively low impact, especially from the tsunami that was generated, was also partly thanks to a really impressive global response effort.
Oh, right, the warnings.
Exactly. Over 3 million people across the Pacific Rim received warnings, and many were evacuated. The Pacific Tsunami Warning Center, the PTWC in Hawaii, they were crucial. They rapidly assessed the quake's size, depth, location, issued targeted warnings.
How do they do that so fast?
They use seismic data from around the world, plus data from the DART buoy network. Those are deep ocean assessment and reporting of tsunami sensors out in the ocean. They actually measure the tsunami wave as it passes.
Wow.
And advances in modeling, like New Zealand's RCE program, Rapid Characterization of Earthquakes and Tsunami, these toolkits really prove their worth. They help process data and get actionable warnings out faster than ever before.
So really the big takeaway there is preparedness and these warning systems work. They save lives.
Absolutely. It's a huge success story, especially when you contrast it with something like the 2004 Indian Ocean tsunami. Back then, there was no coordinated regional warning system. Warnings either didn't exist or didn't reach the people on the coasts in time. The difference is night and day.
So what's next? Where is the science heading, if prediction is still off the table?
Well, prediction of the exact time, place, and magnitude, yes, that remains elusive. But research, like from the USGS and scientists worldwide, is constantly improving our ability to forecast earthquake effects, where the shaking is likely to be strongest, landslide potential, liquefaction risk, and also understanding the probabilities better over the long term.
How? What techniques are they using?
Lots of things. Refining seismic hazard maps, analyzing seismicity patterns more closely, looking at frequency magnitude distributions, how often quakes of different sizes happen in a region, identifying earthquake clusters or swarms and trying to understand what they mean.
And I bet machine learning is involved now. AI.
Oh, definitely. Machine learning, deep learning algorithms. They're being used more and more to sift through vast amounts of seismic data, looking for subtle patterns that might precede larger earthquakes, things like Kamchatka quake. It's still research, but it's a growing field.
Interesting. Is there anything else on the horizon that looks promising for maybe sort of forecasting?
One really fascinating area is research into slow slip events, or SSEs.
Slow slip. What's that?
These are incredibly slow, almost silent movements on a fault, usually deep down. They don't generate sharp seismic waves like regular earthquakes. They can last for days, weeks, even months.
Okay, so how does that help?
The thinking is, as these slow slip patches accelerate or migrate along the fault, they can subtly change the stress conditions on adjacent parts of the fault. They might increase the shear stress on locked sections.
Loading them up?
Kind of. Potentially pushing a locked section closer to rupture.
Yeah.
It's like a gradual nudge rather than a sudden jolt.
Is there evidence this actually happens?
There are intriguing cases. For example, the 2014 magnitude 7.3 Guerrero, Mexico earthquake. It seems to have been preceded by a large magnitude 7.6 equivalent slow slip event on a nearby part of the fault. So the research is focused on understanding that physical link. Could monitoring these accelerating SSEs provide some kind of precursory signal, not a precise prediction, but maybe a warning that the probability of a major earthquake has increased significantly in a certain area over the coming weeks or months? It's about time-dependent forecasting.
That sounds incredibly complex, but potentially game-changing.
It is complex. The relationship isn't straightforward, and the Earth's systems are incredibly nonlinear. But it's a major focus of research, trying to move beyond long-term probabilities towards something a bit more timely, even if it's not pinpoint prediction. So here's something to think about. If our ability to respond effectively to earthquakes through better warnings, better engineering, global cooperation, if that's improving so rapidly, even if precise prediction stays out of reach, what new level of readiness does that demand from all of us, as individuals, as communities?
Yeah. And how much of our own safety really depends not just on hoping we know when the ground will shake, but more on our actual willingness to be ready for, if it does. Taking those preparedness steps seriously. It's definitely a lot to consider, but it's also kind of empowering, isn't it? Knowing how much science is learning and how much we can actually do ourselves.
Absolutely. It's not just about fear, it's about understanding and action. And that seems like a good place to leave it for this deep dive into the world of earthquakes.
See you next time on The Deep Dive.